Hello and welcome back. Let's see one more example for integration by parts. And this example looks a lot like the previous one, in which we did the integral of x e to the 7x. But in this case, we've got x squared e to the 7x. And again, the first strategy that we want to do, and we want to use is to find u and v. But in particular, we want u and v to be chosen to make that second integral as easy as possible. So we need to find something for u that when we take the derivative, it should get simpler. And here, like last time, we chose x to be u. This time we are going to choose x squared, because when we take the derivative of x squared, we get 2x, which is much simpler. It's closer to being just a constant. But that means that our dv is going to be e to the 7x dx. And then like we saw last time, when we integrate or take an antiderivative of e to the 7x, we're going to get 1 over 7 e to the 7x. Cool. So let's plug everything in and see what happens. So our u is going to be x squared times times v, which is 1/7 e to the 7x. And then this is where we plug in our x equals 0 and our x equals 1, minus the integral, and then we have our v du. So v du, this is meant to be a differential, so I need to have that dx in there. So this is times 2x dx. And here, I want to simplify this just a little bit. I'm going to leave this part just as is for now, and maybe move the 1/7 out front just because it's a little bit nicer to look at. But what you'll notice is that after I pull out the 2 and the 1/7, I've got the integral of e to the 7x times x dx. And this should look a little bit familiar. This is the same integral that we saw in the last question. So, we already know the answer, but if we didn't know the answer, we would have to recognize this as doing integration by parts again. So this is one of the things that can come up with integration by parts. Even though we use integration by parts to turn a hard integral into an easier integral, sometimes that easier integral still requires integration by parts, or a u substitution, or anything like this. So you might find that this easier integral is something that you just have to use integration by parts again. So let's go through this one more time, just so that we've got this under our belts. We have our u and our dv, and the u that we want to choose is x, because when we take the derivative of it, we just get 1. So this is going to be 1 dx. That makes it a lot simpler. Whereas our v is going to be, let me put the 2/7 inside, and I think that'll be a little bit easier to do here. So our dv is going to be 2/7 e to the 7x dx, just everything else that's not u. And then when we take the integral, we end up dividing by 7. So this is going to be 2/49 e to the 7x. So plugging all that into here, not forgetting about the first part, we get 1/7 x squared e to the 7x, evaluated at 0 and at 1, minus everything that comes after this. So this is going to be u times v. So this is going to be u times v, again evaluated at x equals 0 and at x equals 1, minus the integral of v du. Remembering that, okay, anything times 1 is just itself. And then here, we can start plugging everything in. So it's going to be 1/7 x squared e to the 7x, evaluated at 0 and at 1, minus, and what I'll do is I'll distribute the negative sign. So we'll subtract this guy, maybe moving the constant out front just because it's a little bit easier to see that way. And this is going to be evaluated at x equals 0 and x equals 1. And then minus a minus, so it's going to be plus. So again, the 2/49 pops out, and then we've got 1/7 e to the 7x. Again, this is also evaluated at x equals 0 and at x equals 1. And one thing that I'll point out is we're evaluating everything at x equals 0 and x equals 1. So why don't we just evaluate everything at x equals 1 and x equals 0. So let's plug in 1 everywhere. So if I plug in a 1, I get 1/7 times 1 squared times e to the 7 minus 2/49 times 1 times e to the 7th plus 2/49. I'll just have to do this really quick. 49 times 7, 343. I hope. A long time since I've done multiplication. And then plugging in that 1, we get e to the 7th. And then we're going to subtract what happens when we plug in 0. Well, if I plug in 0 to this first one, 0 squared, well, that's just going to be 0. Minus, if I plug in a 0 there, that's just going to be 0. Plus, if I plug in a 0 here, again, it'll be 2 over 343 times e to the 0 power. And this is going to be something that we'll just simplify. So 1 squared is 1, so this is e to the 7th divided by 7 minus 2e to the 7 over 49 plus 2e to the 7 over 343 minus 0 plus 0 minus 2 over 343. So for instance, I could pull an e to the 7 out of this first bit and simplify that fraction, but I'm feeling a bit lazy, so we will just stop there. So this is just a brief introduction to integration by parts. Identifying u and v is the most important part, and u and v, u should be the thing that makes the integral easier to take the second time round. So when we pick u, we're going to end up taking the derivative of it. So if it vanishes when you take the derivative, like an x, or like an x squared, when you take the derivative you get 2x, which is a lot simpler. So in general, picking something like that to be u is going to make the equation much